Your brand new Ford is rolling off the assembly line with a set of pre-programmed factory settings that are actively engineered to sacrifice the long-term lifespan of your powertrain, just to help the manufacturer meet federal regulatory quotas. For over 16 years, I've been tearing down EcoBoost engines and Power-Stroke diesels in my service bays, and I am sick and tired of watching owners hand over thousands of dollars for catastrophic repairs that could have been avoided by changing a few parameters in a touchscreen menu. Ford sells you these trucks on the promise of relentless capability and cutting-edge convenience, but the hidden mechanical reality inside your garage tells a completely different story. The damage happening under your hood right now is entirely cumulative, completely invisible, and it is quietly ticking away until your factory warranty expires and leaves you holding the bill. Today, I am exposing 5 factory settings that are destroying your vehicle from the inside out without you ever knowing. Setting number 3 has caused more timing chain stretch and bearing failure in my shop than almost anything else. And setting number 1 is so deceptive that most owners actually think it is beneficial to their engine when it is doing the exact opposite. Let's get into it. Setting number 5 is the Intelligent Oil Life Monitor System. Ford markets this as a smart adaptive feature that uses complex algorithms to analyze your driving habits, engine temperatures, and operating conditions to tell you exactly when your oil needs to be changed. The system routinely allows for oil change intervals stretching all the way to 10,000 miles, or even 12 months. To the average truck owner, this sounds fantastic. It means fewer trips to the dealership, lower maintenance costs over the life of the vehicle, and less wasted fluid. You wait for the little message to pop up on your productivity screen telling you your oil life is down to 5%, and only then do you book an appointment. But here's what Ford doesn't tell you. That algorithm isn't programmed to make your engine last for 300,000 miles. It is programmed to minimize the calculated cost of ownership metric during the initial fleet warranty window. Underneath that marketing claim lies a brutal mechanical reality. Modern EcoBoost engines are gasoline direct injected and turbocharged. By their very design, they suffer from higher rates of fuel dilution, where raw gasoline washes past the piston rings and mixes directly into the engine oil. When you push an oil change interval to 8,000 or 10,000 miles, that oil loses its shear stability. The viscosity drops from a proper 5W30 down to the equivalent of a 0W16 water-like consistency. I have pulled oil samples from trucks running these factory recommend intervals, and the data is terrifying. By 6,000 miles, the oil is heavily loaded with abrasive carbon soot and raw fuel. When that thin, contaminated fluid passes through your variable camshaft timing actuators, it acts like liquid sandpaper. It begins grinding your engine bearings to dust and stretching the primary timing chain beyond its mechanical limits. By the time the oil life monitor finally hits 0%, your critical engine components have been starving for adequate hydrodynamic protection for thousands of miles. The damage doesn't cause an immediate failure. Instead, it slowly eats away at the microscopic tolerances until you hit 85,000 miles, well out of warranty. And your engine starts rattling like a sewing machine on cold starts, because the timing tensioners can no longer take up the slack. The solution to this is incredibly simple, and it won't cost you a dime in software upgrades. Ignore the dashboard monitor completely. Do not wait for the truck to tell you when it's ready for fresh fluid. Override the factory logic by tracking your mileage manually and dropping your oil change intervals down to a strict 5,000 miles or 6 months. Whichever comes first. If you regularly tow heavy loads or idle excessively in traffic, drop that number to 4,000 miles. By dumping the oil before fuel dilution can break down its molecular structure, you ensure that your turbocharger journals and cam phasers are constantly bathed in clean, fully shear-resistant lubricant. Setting number 4 is one that Ford markets as a massive win for your wallet and the environment. But under normal driving conditions, it is creating the exact environment that destroys your starter motor, your battery, and your engine's crankshaft thrust bearings. I am talking about the auto start-stop system. The factory setting dictates that every single time your truck comes to a complete stop at a red light, a drive-through, or in stop-and-go traffic, the engine instantly shuts off to eliminate idling emissions and save a fraction of an ounce of fuel. The moment your foot lifts off the brake pedal, the truck fires back up and you drive away. Ford claims the starter motor, the flywheel, and the battery have all been heavily beefed up to handle the massive increase in cycles, presenting it as a seamless, high-tech convenience that reduces your carbon footprint without sacrificing durability. Let's look at the actual engineering reality inside the crankcase. The highest rate of mechanical wear an internal combustion engine will ever experience does not occur while you are cruising down the highway at 70 miles per hour. It occurs during a hot restart. When your engine is running normally, the oil pump creates oil pressure that forces a microscopic film of oil between the crankshaft journals and the engine bearings. This is known as hydrodynamic lubrication, and it prevents metal from touching metal. The components literally float on a cushion of pressurized oil. The second that auto start-stop kills your engine at a red light, your oil pressure drops instantly to zero. The oil film thins out, and gravity begins pulling the heavy crankshaft down onto the bearing shells. When the light turns green and the starter violently cranks the engine back to life, those moving parts experience boundary lubrication conditions, meaning you have actual metal-on-metal friction occurring for a critical split second before the oil pump can repressurize the oil galleries. A standard vehicle without this system might experience 50,000 start cycles over its entire operational lifetime. A Ford equipped with auto start-stop running its default factory configuration can easily smash through 500,000 start cycles in the exact same time frame. I have personally inspected rod bearings and crankshaft thrust bearings on engines with less than 60,000 miles that looked like they had run a 24-hour endurance race without oil, all because they were subjected to 30 hot restarts during a single morning commute. Your starter motor is working 10 times harder, your expensive AGM battery is being deeply cycled continuously, and your engine's internal components are being subjected to a relentless onslaught of friction. All of this mechanical destruction is happening just to save a negligible percentage of fuel that you will instantly burn through when you pay for a single starter replacement or a premature bottom-end rebuild. The solution here requires a minor shift in your driving habits because Ford does not provide a permanent factory latching switch to disable this system forever. Every single time you climb into your truck and press the ignition button, make it an absolute habit to look down at your center console or your upper dash array and press the auto stop disable button, the little icon with the letter A surrounded by a circular arrow. Yes, you have to press it every time you start the vehicle, but making that single button press part of your startup routine keeps your oil pressure stable, stops the metal-on-metal grinding at every stoplight, and saves your starter from an early grave. Now that you know how to stop your oil from breaking down and how to kill the metal-on-metal grinding at every red light, we need to talk about the hidden traps buried deeper within your truck's electronic control modules. These next two factory configurations are even more insidious because they operate completely in the background, quietly changing how your drivetrain manages physical stress and thermal loads while convincing you that everything is operating perfectly. Setting number 3 is the factory-programmed skip-shift logic inside your 10R80 and 10R100 10-speed automatic transmissions if you own a modern Ford truck. You've undoubtedly noticed how the gear indicator on your dashboard behaves during normal acceleration. You pull away from a stoplight under light throttle, and instead of sequentially moving through the gears, the transmission completely ignores second gear, jumps straight from first to third, skips fourth, and slams directly into fifth. Ford engineered this progressive skip-shift strategy with one primary goal in mind: fuel economy optimization during EPA emissions testing. By keeping the engine RPMs as low as possible and rushing into the highest possible gear, the truck reduces its parasitic pumping losses and squeaks out a slightly higher miles per gallon rating on paper. The manufacturer markets these 10-speed units as intelligent, smooth-shifting marvels that effortlessly adapt to your driving style to deliver maximum efficiency, but as a technician who has spent years pulling these exact transmissions apart on a workbench. I can tell you that this factory strategy is a mechanical disaster for the internal clutch packs. When the transmission shifts gears under normal driving loads, it forces the engine to operate at a massive mechanical disadvantage. You are effectively bogging the engine down, creating low RPM, high-torque situations where the powertrain is lugging. To compensate for this lack of mechanical leverage, the transmission control module has to slip the oncoming clutch packs longer than it normally would to smooth out the transition inside your transmission. Gears are engaged by hydraulic fluid pressure, squeezing steel plates and friction discs together. When you skip second and fourth gear, the third and fifth gear clutch packs are subjected to immense thermal spikes because they are absorbing all the rotational inertia that should have been stepped down incrementally through the skipped gears. Over time, this constant slipping cooks the friction material, turning your clean red transmission fluid into a burnt black abrasive slurry. Even worse, the sudden torque transitions create massive shock loads across the internal planetary gear sets and the main CDF clutch drum. In my shop, I regularly see these 10-speed transmissions coming in with snapped drum sleeves, warped steel plates, and severe gear hunting issues before the odometer even hits 50,000 miles. The driver experiences this as a harsh, neck-snapping clunk when the truck tries to decide between third and fifth gear, or a terrifying hesitation when you step on the gas to merge and the computer panics trying to drop 4 gears at once. To save your transmission from destroying its own clutch packs, you need to override this default skip-shift behavior on every single drive. The absolute best way to do this without buying aftermarket tuning software is to utilize your truck's built-in drive modes. Every time you shift into drive, cycle your drive mode selector over to Sport mode or Tow Haul mode. In these specific factory configurations, the computer completely rewires its shift strategy. It forces the transmission to utilize all 10 gears sequentially, 1, 2, 3, 4, 5, and so on. This spreads the acceleration load evenly across every single clutch pack, reduces clutch slippage to a bare minimum, and keeps the transmission fluid running significantly cooler, adding tens of thousands of miles of life back into your expensive drivetrain. Setting number 2 is the highly deceptive, heavily buffered dashboard engine coolant temperature gauge. Every vehicle on the road has a gauge on the dash designed to tell you how hot your engine is running. On a modern Ford, you see that little needle sweep up to the exact center of the dial after a few minutes of driving, and it sits there, perfectly rock solid. Whether you are driving down an empty highway in the winter or towing an 11,000-pound travel trailer up a 6% mountain grade in the dead of summer. Ford designs these gauges to be heavily buffered or dampened, meaning the needle is not displaying real-time temperature fluctuations. Instead, the computer is programmed to keep that needle pointing dead center across a massive, sweeping window of actual operating temperatures, often anywhere from 185 degrees all the way up to 230 degrees Fahrenheit. The manufacturer does this intentionally to avoid what they call customer panic. They don't want you looking at a fluctuating needle and calling the service department every time your truck works hard. The mechanical reality of this factory setting is that by the time that dashboard needle actually moves off the center mark and into the red zone, your engine is already actively overheating and irreversible structural damage is occurring. Modern EcoBoost and PowerStroke engines utilize aluminum cylinder heads bolted to engine blocks with multi-layer steel head gaskets. Aluminum expands and contracts rapidly when subjected to intense thermal loads. Because the factory gauge acts more like an on-off switch rather than a real-time scientific instrument, you are operating completely blind to thermal spikes. If you are towing a heavy load up a steep incline, your engine coolant and cylinder head temperatures can skyrocket past 225 degrees in a matter of seconds. At these temperatures, engine oil thins out drastically, losing its capability to protect your camshaft journals. More importantly, the extreme heat causes microscopic warping across the aluminum cylinder head mating surfaces. This warping compromises the sealing integrity of the head gasket Because you think the truck is running completely fine based on that frozen dashboard needle, you keep your foot buried in the accelerator pedal. You are literally cooking your engine's top end, while the factory gauge reassures you that everything is perfectly normal. By the time the computer finally decides the engine is hot enough to trigger a dashboard warning light and move the needle, the head gasket has already blown, or worse, the cylinder head itself has cracked from the thermal stress. I have replaced countless warped cylinder heads on trucks where the owners swore up and down that the temperature gauge never moved until the exact second the engine began blowing white smoke out of the tailpipe. To fix this blind spot and protect your engine from invisible thermal deformation, you need to force the truck to display the true, unbuffered digital temperatures. On many modern high-trim Fords, you can actually use the vehicle settings menu to enable digital readouts directly above the physical gauges. If your specific trim package doesn't support this factory configuration toggle, the solution is to plug an inexpensive OBD2 monitor or digital gauge display into your diagnostic port under the dash. These devices read the raw, unbuffered data directly from the engine control module's coolant and cylinder head temperature sensors. This allows you to see the exact numerical temperature of your engine in real time. When you see that digital number climb past 215 degrees Fahrenheit while pulling a hill, you know it is time to back off the throttle, drop a gear manually, and let the cooling system catch up before the invisible heat destroys your cylinder head. We have covered the maintenance traps, the starter motor killers, the transmission failures, and the blind spots in your cooling system. But we have finally arrived at number one. This is the single most destructive, highly deceptive factory configuration in the entire vehicle, and it is the one where Ford's marketing has completely flipped reality on its head, convincing you that a feature is protecting your engine when it is actually accelerating its demise. Setting number one is the factory Intelligent Oil Life Monitor's interaction with the extreme oil dilution parameters of the diesel particulate filter regeneration cycle on Power Stroke engines. Combined with the normal driving mode crankcase ventilation logic, Ford markets their clean diesel technology as a seamless automated system that keeps your truck running clean without requiring any input from the driver. They tell you that when the diesel particulate filter fills up with soot, the computer initiates an automatic active regen cycle that burns off the trapped particulate matter. The manufacturer reassures you that the truck's onboard computer is monitoring this entire process perfectly. Adjustments are made automatically, and you can just drive the truck normally like any other vehicle. But here is what Ford does not tell you about the physical engineering nightmare happening inside your oil pan during an active regeneration cycle. To burn off that soot, the engine control module needs to raise the exhaust gas temperatures inside the particulate filter to over 1,100 degrees Fahrenheit. It achieves this by executing a late-cycle fuel injection event. The fuel injectors fire raw diesel fuel directly into the cylinders during the exhaust stroke. This unburned diesel fuel is meant to travel down the exhaust pipe and ignite inside the catalyst. When your truck is set to its standard factory driving mode and driven under what the average owner considers normal conditions, like running errands around town, short commutes to work, or letting the truck idle in the driveway to warm up, the engine never reaches sustained operating temperatures. During that late cycle injection, a massive percentage of that raw diesel fuel does not escape out the exhaust valve. Instead, it sprays directly onto the cold cylinder walls, washes past the piston rings, and drains straight down into your engine oil. This is known as fuel dilution, and on a modern Power Stroke, it is catastrophic. Diesel fuel is an incredibly poor lubricant compared to motor oil. It acts as a powerful solvent. As you continue to drive the truck under short-trip factory conditions, the computer keeps trying to initiate regions that it cannot finish because you arrive at your destination and turn the truck off. The system repeatedly dumps more diesel into the crankcase, causing the oil level to actually rise on the dipstick. What makes this setting completely deceptive is that the factory oil life monitor does not actually analyze the chemical composition or the fuel percentage of your oil. It simply guesses based on a mileage algorithm. I have personally drained oil from late-model Power-Stroke diesels where the factory monitor claimed the oil still had 40% life remaining. Yet laboratory fluid analysis proved the oil was diluted with over 7% raw diesel fuel at that concentration. The viscosity of your expensive 10W30 or 5W40 oil is completely ruined. The raw diesel washes away the protective oil film on your main bearings, your rod bearings, and your lifter rollers. This creates intense boundary friction, where metal surfaces are grinding against each other at thousands of revolutions per minute. The structural integrity of your engine's bottom end is being systematically dissolved by your own fuel system, all while the factory dashboard screen smiles at you and says your oil condition is perfectly healthy. By the time the oil life monitor finally alerts you that a change is due, your engine bearings have been swimming in a solvent-rich bath of degraded oil for months, cutting the real-world lifespan of that expensive diesel engine clean in half. To completely halt this destruction and take back control of your powertrain's longevity, you must drastically alter how you handle the truck's factory regeneration cycles. First, you need to use a digital monitor or enable the hidden factory operator-commanded regeneration or DPF% full screen on your dashboard using a service tool like FORScan. This allows you to see the exact percentage of soot in your filter in real time. When you see that your truck has initiated an active regeneration cycle, do not turn the vehicle off. Do not pull into your driveway and shut down the engine while the system is actively dumping diesel into the cylinders. You must keep driving the truck at highway speeds for an extra 15 to 20 minutes until the cycle is completely finalized and the soot load drops down to 0%. This ensures that the fuel is fully burned off in the exhaust rather than washing down into your oil pan. Furthermore, you must completely abandon the factory's automated oil change suggestions. Throw the dashboard monitor out the window and dump your diesel engine oil every 4,000 miles or 6 months, without exception. By removing that fuel-diluted oil before the solvent concentration can compromise your bearings, you ensure that your high-dollar diesel engine actually lives to see the high mileage numbers it was built to achieve. When you look closely at how modern vehicles are built, the ultimate truth becomes completely undeniable. The factory configurations engineered into your truck are not designed to optimize the physical lifespan of the mechanical components inside your garage. They are designed to optimize federal compliance parameters, corporate average fuel economy numbers, and initial cost of ownership metrics during the first few years of operation. The convenience features and automated settings sold to you as high-tech upgrades at the dealership showroom always come with a steep, hidden mechanical cost that the manufacturer never advertises the moment your truck rolls off the dealership lot. The ultimate responsibility for protecting that massive financial investment shifts entirely off the manufacturer and right back onto your shoulders. But as we have proven today, the tools and strategies to completely defeat these engineered vulnerabilities are incredibly simple, highly effective, and require nothing more than a decisive change in your daily operational habits by manually overriding your oil change intervals to 5,000 miles. Making the disabling of the auto start-stop system an automatic part of your startup routine, shifting your transmission into sport or TOW hot haul mode to eliminate harmful skip shifting, monitoring your true unbuffered engine temperatures in real time, and forcing your diesel regeneration cycles to finish completely, you are effectively rewriting the logic of your truck. You are taking back control from a computer program designed to meet regulatory quotas and putting that control back into the hands of real-world mechanical longevity. If this deep dive insider information helped you understand what is truly happening beneath the hood of your vehicle, take a second right now to hit that subscribe button, turn on that notification bell, and share this information with another truck owner who is still blindly trusting their factory dashboard settings. Drop a comment below, letting me know which of these factory settings you are going to change first on your own vehicle this week. Keep your oil clean, keep your temperatures verified, and don't let a factory software configuration dictate the lifespan of your powertrain. I will see you in the next one.